All right, so part 2, we're going to be 3A.5. We're going to be compressing and stretching, okay? You may hear sometimes say shrink. So the shorter word for compressions is to shrink, okay? Shrinks and stretches, okay? If you don't want to write compressions all the time, shrinks and stretches. And we're going to talk about who does what. So when you have a vertical compression, that means that we have y equals a times f of x. So I'm multiplying the entire function by a number. Okay? And there are rules for it. If the absolute value of a is between 0 and 1, then it's going to be a vertical compression by a factor of a. What that means mathematically is we're multiplying all y values times a. So whatever a is, we're going to multiply it. I'm sorry. Yeah, either way. So if it was a half, if it's a whatever, but this is going to apply to both. If the absolute value of a is greater than 1, then it's a vertical stretch. Again, still just means all you're doing is multiplying all your y values times a. We're not changing anything x-wise. Vertical stretch and compression only applies to your y. Okay. All right. So how I think about this is, think about you're like, okay, I'm gonna get in shape. I'm gonna go work out a lot. I'm gonna stretch, right? I'm gonna get skinny. So what happens is when you work out more, you get skinny. Your graph is going to grow faster vertically. Does that make sense? Now you're like, oh, I don't have time to keep working out. Oh no, I'm gonna go half the time I was already doing it. And then what happens? You get wider because you stop working out and it just gets wider. Here's a real life example, your teacher. That's what happened. Just got a little wider because I stopped working out. Don't do that though. Stay active. All right, horizontal works the opposite. Okay. But we got to remember what horizontal is, that our x's are liars. Okay. Anytime we're dealing with our x, we're dealing with the liar. So again, x's are liars. All right. So with that in mind, if I have the function and it says b times x, that means I'm changing my x's. It's always going to be the opposite of what's happening. So if the absolute value of your b is greater than 1, then it's going to be a horizontal compression. So even though your b is bigger, it's a compression. It's a horizontal compression. That means you're applying more pressure to it. Does that make sense? Think about playing that. What's that thing called? That Steve Urkel played? Accordion. When I push it, I'm applying more pressure, right? I'm going, and then your stretch is I'm pulling it out. I'm stretching the accordion out. And so I'm not applying as much pressure. Okay. What you're doing here is that you are taking all of your x values. So whatever it is going to be x divided by b. It looks like multiplication, but it's actually division. Okay. Because x's are liars. All right. So up first, we have this graph. We're going to be using the same graph, by the way. All right. You're going to write them in. Huh? Because I use the graph points that were given to me. See the point? It gave me my points. So it gave me the points to use. So the points that we're using are -5, 0, -3, -5, 1, 5, 0, 3, 1, 1, 3, 2, 5, -3. It gave me my points, so therefore I know what I'm changing. It's the same concept. All right, so here it says that your new graph is going to be y equals 3f of x. Because it says y equals 3f of x, it's telling me that my a equals 3. What did we say it meant when you have a number outside of f of x? It means you're multiplying all of your y values by 3. Remember, f of x means y. So that means that we're going to take all of our y's, which whatever y is, and multiply it by 3. So each one of these, I'm going to multiply by 3 in order to get my new value. So 0 times 3, -5 times 3, 5 times 3, 3 times 3, 1 times 3, 2 times 3, and -3 times 3. That's going to give me 0, -15, +15, 9, 3, 6, and -9. I didn't do anything to the x, so I'm still using these same x values. So when I graph this, it says -5, 0 is my first point. -3, -15. Well, -3, -15, that's off the page. There's nothing I can do about that, right? It's all the way down there. Okay, then it says I'm going to be at -1, +15. Again, it's going to be all the way off the page. Nothing I can do with that. Now we're at 0, 9. So I go to 0, 1, 2, 3, 4, 5, 6. Can't do nothing with that. It's all the way off the page. And now we're at 1, 3. I can go to 1, 3. You're literally stretching the graph. Do you get that? So now we're at 1, 3. Now we're at 3, 6. Again, 3. 3, 4, 5, 6 is kind of right there. Kind of. We're gonna guesstimate. And then we're at 5, 9. And 5, 9 is way off the page. So you're literally going to go through and graph out the stretches of the function. So it's going to go all the way down, right? Then it's going to come all. Did I skip one? I did skip 2, -2, 0. It's okay. Still going to be there. Going to go all the way off. And then it's going to have to come all the way down. And then I go up. And then I'm going to go all the way down. So do you see how it literally got stretched? And that's what happens when you have a number times a function. It's going to literally stretch the function. Yes. Yes. And what do you think happens the other way? If we went the other way, exactly. Okay. All right. So we'll stop there, I guess. But it's not a hard concept of stretching and compressing.